In this video, we're going to be talking about distance versus displacement. Now, a couple things to know before we start getting into the problems. Distance is the total distance traveled, everything together. Distance can only be a positive number. Displacement, on the other hand, it is a change in distance. This can be positive or negative, as you'll see in some of these problems. The formula for finding distance, you're just going to add all of the numbers together, the distance you traveled. For displacement, however, our formula, we have two formulas. If we're moving in one direction or one straight line, we're going to use this formula, which is change in x, or displacement, is equal to the final position minus the initial position, or the starting position. Our second formula is going to be using the Pythagorean theorem, because our movements are going to go just like a triangle. And so we're going to need to find that hypotenuse, which will use a squared plus b squared equals c squared. So let's go ahead and get started with our first problem. All right, so number one, we have a number line. We're going to start at A. This creature, person, or bird traveled from A to B, which is 10, 20 kilometers. And then they didn't stop there. They continued going toward C. So they went 20, they're going to go back. 20, 30, 40, 50, 60, 70, 80. Okay? They ended up traveling 80 kilometers. But we're going to use our formulas. So for distance, we're going to add A to B, which is 20 kilometers, plus B to C, which is 10, 20, 30, 40, 50, 60. 60 kilometers. Add those together, and our distance is 80 kilometers. When you get your answer, you're going to box it. Just makes it easier for me to grade finding it. And now for our displacement. Our displacement, first thing you're going to do is write your formula. Our formula is change in x is equal to xf, the final position, minus xi, our starting position. Our final position where we ended up is here at 50. So it would be 50 kilometers minus our starting position, which is at 10 kilometers. When we do the math, we are left with 40 kilometers. But this isn't over. This is not just distance. We also have to have a direction for displacement. And so, since we ended up going this way, 40 kilometers east. We started here and went over here. 40 kilometers east is our answer. Let's look at question number 2. We start over here at A and we travel all the way over to B. And then we end up traveling back to A. Now our distance is what we're going to calculate first. Notice this number line is by 5s. The last one was by 10s. So we go 5, 10, 15, 20, 25. So A to B is 25 kilometers. Plus, we also have to go back. So B, 5, 10, 15, 20, 25. 25 kilometers. Our distance, if you add these both together, is going to be 50 kilometers. Now for our displacement. We're going to write the formula first. So our displacement is change in x, or displacement, equals xf, our final position, minus our initial position. So our final position here is at 15. our starting position is also here at 15. So our position is 15 minus 15. Our displacement is 0 kilometers. Here is our displacement. Let's continue on. Now we're going to run into some word problems. On this one, I went ahead and put a compass up at the top because I find actually drawing it helps me to visualize what I'm doing. Bob walks 20 kilometers west to Canes. He eats and then walks back 30 kilometers east to his house. What is his distance and what is his displacement? We're going to first start off with distance. Well, first we're going to draw a picture. Let's draw this picture. So he starts off here and ends up going west 20 kilometers. I'm going to do this by tens. Here's 0 and here's 20. He ends up going 20 kilometers and then he goes back 30. 10, 20, 30, and ends up here at negative 10. Sorry, he ends up at positive 10. Over here are the negatives. Negative 20 and negative 10 are over here. Here is west on this side, and here is east. So his final point's here at 10. All right, now for the math part. Distance. He traveled 20 kilometers west and then 30 kilometers east. We're going to add those two together and get 50 kilometers. Now for our displacement, our formula there is change in x is equal to the final position minus the initial position. Our final position ended up being here at positive 10. So we're going to put that there. 10 kilometers minus our starting position, which is here at 0, because he traveled from 0 to 20, and then he went back 30. So after subtracting those, our displacement is 10 kilometers, but we need a direction. We ended up going from 0 to 10, that's traveling east. So 10 kilometers east. We're going to box it. Let's look at another one. Number 4. Susan drives 50 kilometers north and then drives 45 kilometers south. What distance did she cover? What is her displacement? So she starts here at 0. I'm going to draw it first. She goes north. North is up about 50. Well, she goes 50 kilometers north. I'm going to do it in tens again. 10, 20, 30, 40, and 50. She ends up here at 50. Then she drives south 45. She goes back down and ends up here. Here is going to be 5. Now that we've drawn our pathing, let's figure out what the distance is. Our distance is 50 kilometers plus 45 kilometers. And that is equal to 95 kilometers. And our displacement is change in x is equal to x final minus x initial. Our final position is here at 5. Here's where we ended, 5 kilometers, minus our starting position, which is at 0 kilometers. So our displacement is 5 kilometers south, because we ended up going down. Here is our answer. Now let's look at our next one. Okay. A bird flies 45 kilometers north to gather worms. Then the bird makes a sharp turn heading east 8 kilometers. What is the bird's distance and displacement? Let's draw this first so that we can get a visual on what we're looking at. 5 kilometers north. So let's start here and go up 5 kilometers. And then makes a sharp turn heading east 8 kilometers. All right, now that we have our visual here, this is north, this is east. So let's do distance. Distance. We're going to add these two together. 5 kilometers plus 8 kilometers is equal to 13 kilometers. Here is our distance. Now displacement, we've been doing different things for the previous problems. This one's a little different. Notice it's not in a straight line anymore. Since we can make a triangle, we have to use the Pythagorean theorem to figure this out. The Pythagorean theorem says this side, a squared, plus this side, b squared, is equal to the hypotenuse, which is what this is, which is c squared. So we're going to use this as a formula. Our displacement for this one is a squared plus b squared equals c squared. So let's plug in these numbers. C squared is equal to a squared plus b squared. Okay, so c squared, I'm just going to say this side is a, the 5 kilometers. 5 is squared. And this side is b, the 8 kilometers. Now that we have those, we're going to figure them out. 5 squared, or in other words, 5 times 5, is equal to 25. Plus our 8 squared, which is equal, it's the same as 8 times 8, which is 64. We're going to keep dropping this down. 25 plus 64 is equal to 89. Now this, we're not done yet. We need to get c by itself. Currently, c is squared. We need to get rid of that. So the opposite, usually we use opposites. Multiplication, division, adding, subtracting. We need to get rid of this square. So we're going to do the square root. But what we do to one side, we have to do to the other side. So the square root of c squared and the square root of 89. Square root of c squared is just c. We got it by itself. The square root of 89, after you plug that into your calculator, or calculate it out, is 9.4339, and so on and so forth. But we are going to round to the nearest tenth. Nearest tenth is this 4 here. So we are going to say c is equal to 9.4. We also have to have a direction for our displacement. We ended up going north and then east. This is northeast. So 9.4 northeast. And this is our answer for displacement. Let's do one more. All right. Frank the Frog jumps 3 kilometers south to catch a fly. Then he jumps 8 kilometers west to go home. What is his distance and what is his displacement? So let's draw this first just to get an idea of what we're doing here. We're going to draw it. So he goes south, 3 kilometers south. We'll put it on the other side because we're about to move west. And then he goes 8 kilometers west. Let's do our distance first. Distance, we're just going to add those both together. 3 kilometers plus 8 kilometers is equal to 11 kilometers. Here is our distance. Now let's look at displacement. Displacement, notice it's not in a straight line again. So we're going to have to use our other formula, our Pythagorean theorem, because it makes a right triangle. And that is a squared plus b squared is equal to c squared. Let's continue this down. C squared is equal to a squared plus b squared. Now I'm going to have this one down here be a and this one here be b. Either one will work. So c squared is equal to a squared, which is 8 squared, and b squared is 3 squared. C squared is equal to 8 squared, and 8 squared is equal to 64, plus 3 squared is equal to 9. We're going to keep doing this. I'm going to bring down the c squared. 64 plus 9 is equal to 73. To get c by itself, we have to do the opposite of squaring, which is square root. So c squared, square root, but what we do to one side, we have to do the other. So 73, the square root of 73, c is by itself. That is equal to 8.54400. We're going to round it to the nearest tenth. C is equal to 8.5 kilometers. And we got a direction. Direction is southwest. And that is how you do distance and displacement.